Solving a word problem using a system of linear inequalities, problem type 1. Amy will donate up to $440 to charity. The money will be divided between two charities, the City Youth Fund and the Educational Growth Foundation. Amy would like to donate at least $140 to the City Youth Fund. She would also like the amount donated to the City Youth Fund to be at least 3 times the amount donated to the Educational Growth Foundation. Let X denote the amount of money in dollars donated to the City Youth Fund, and let Y denote the amount of money in dollars donated to the Educational Growth Foundation. Shade the region corresponding to all values X and Y that satisfy these requirements. Alright, that's a lot of information to take in at once. But we always know that the first thing we should do when we solve a word problem is define our X and our Y variables and what they mean. Now this is what we're looking for, what we're trying to solve for. But lucky for us, the problem defined them for us. So let X denote the amount of money in dollars donated to the City Youth Fund. So I'm just going to write that right here so I can reference it. So money and then I'm going to say City Youth Fund. I'm just going to abbreviate so I can briefly look up and remember what it is. Similarly, Y denotes the amount of money in dollars donated to the Educational Growth Foundation. So I'm going to do money for Educational Growth Foundation. So that'll just help me. I can quickly look up and see which one's which so I can use them. Alright, now let's go back to the beginning of the problem and take one piece of information at a time and put it into inequalities. It says Amy will donate up to $440 to charity. That's total money for both charities. So if X is the money for the City Youth Foundation, or the City Youth Fund, and Y is the Educational Growth Foundation, together, at most, they can be $440. So X plus Y, at most, is going to be $440. So it could be exactly equal to $440, but how much she spends on her charities cannot be bigger than this. So it has to be smaller than $440 or equal to it. So that's our first one. Okay, that's our first piece of information, and we've got our first inequality. Now, we know we're doing a system, so we're going to have 2 or more inequalities here by the end. So, the money will be divided between 2 charities, the City Youth Fund and the Educational Growth Foundation. Amy would like to donate at least $140 to the CYF, the City Youth Fund. Okay, so the CYF money is X, so X needs to be at least 140. So it could be equal to 140, but it needs to be at least, which means is $130 okay? No. But is $150? Yes. So this X can be bigger than 140. So it needs to be bigger or equal to 140. All right. Now we have more information, so we're going to keep going. Even though we have 2, we're not done until we take care of all of our information from the problem. She would also like the amount donated to City Youth Fund to be at least 3 times the amount donated to the Educational Growth Foundation. Okay, so X, the City Youth Fund, needs to be at least 3 times Y, how much she gives to the Educational Growth Foundation. So X needs to be at least 3 of this much. So it could be equal to, because she could give exactly 3 times as much, or she could give more than 3 times as much. So we're going to do something like that. So X is greater than or equal to 3Y. Alright, let's keep reading and make sure that we've covered all of our bases. Let X denote the amount of dollars and Y denote shade the region. Okay, so we've covered our pieces of information, but I'm going to point something out to you that you need to realize when you're doing your homework. This graph is only the first quadrant. So there's some other constraints that they're kind of giving us a hint to. Now, why wouldn't we need to be able to see the other 3 quadrants here? Because we're talking about money, you can't donate negative money to charity. That would be the same thing as taking money from charity, which they don't let you do. So we know that as the absolute minimum, if X is here for the City Youth Fund, the absolute minimum she could donate is $0. because she can't take any money, and she can give 0, though that's the smallest. So x has to be greater than or equal to 0 because she can't take money from the charity. In a similar manner, she can't take money from the Educational Growth Foundation either. So y also has to be bigger than 0, or else she'd be taking money from that charity. So here we have a system of 5 equations, or excuse me, 5 inequalities. Now we just need to graph them here so that we can, we need to graph them here so we can find which shaded regions intersect and give us the region corresponding to all these requirements. So first I need to get all of these into y equals form. So I'm going to turn all of these into y equals form. So on this one, I would subtract an x on both sides. So this cancels, and I have just a y on this side. So I have y is less than or equal to 440 minus x. Here, there is no y, so the x gets to stay just like it is. Here, I need to divide by 3, but because the 3 is positive, I don't need to switch my sign, but I'm going to put y on this side. So y is less than or equal to, it's pointing at y in both, x over 3, or 1/3 x. And there's no y in this one, so x is greater than or equal to 0, and y is already by itself in this one. So here is our new system, and the one we're going to graph. Okay? So I'm going to start from the bottom and work my way to the top because it's a little bit easier. So y is greater than or equal to 0. Because the only variable here is y, we know that it's going to cross the y-axis somewhere. So it's going to cross the y-axis somewhere. We just need to figure out where. Here it tells us 0. So there's going to be a line right here going through the y-axis that is y is greater than or equal to 0. So we know there's going to be a horizontal line right here. And because we see that it's equal to, we know it's going to be a solid horizontal line. So I'm going to go ahead, and I know you won't be able to see this much, but I'm going to graph a solid line right there. Okay? And I know that y is greater than this line. So I could shade this whole quadrant. But because there's only a quadrant here, I already know I'm restricted to this. Similarly, x is greater than 0, which means we're going to have some line going through the x-axis somewhere, and it tells us at 0. So we're going to have a line going through right here. So we're going to put it flat and draw a line. Now I'm not sure on Alex if you have to graph these lines or not, but if you do, this is why I'm showing to you. If not, now you understand why they've only given you the first quadrant. Alright, so we've checked this one off, and we've checked this one off. So now let's look at y is less than or equal to 1/3 x. I want to graph using my slope and my intercept. I know my slope is always the number next to the x, so my slope is 1/3. I know my y-intercept is always the constant, or the number by itself. Here, I don't see a number by itself, so I know that my y-intercept is 0. So I have my information, and I need to figure out how to graph it. However, I first need to decide if on Alex they might have already labeled the axes here on how much they count by. But I have to make a decision. So I look up here, and I see that I have 440 and I have 140. So I can't count by ones because I'll never get to those numbers. So I might count by, let's see, 50, 100, 150, 200, 250, 300, 350, 400, 450. I might just count by 50s. So this one's 150, 200, 250, 300, 350, 400, 450, 500. And I'm going to do that on both axes. So 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. And we'll just stop there for now. Okay, well, we might as well put a 600. So here, my intercept is 0, and that's my starting place. So I'm just going to come down here and put a dot right on the 0. That's my starting place. And my slope is up 1 over 3 because it's rise over run. So up 1 over 3. However, I can't see 50 tick marks in here, but let me give you a trick. As long as each of these tick marks on the y-axis and these tick marks on the x-axis are worth the same, so here 50, 50, 50, 50, 50, 50, we can just count by squares. So we're going to go up 1, or 50, and over 3, or 150. So it's the same ratio, even though we're going up by 50s instead of just 1. So I'm going to go up 1 over 3, up 1 over 3, up 1 over 3. The more dots you put, the more accurate your graph will be. Now I come back over here. This could be equal to, so I know my line is going to be solid. So I am going to get right in here and graph a solid line going through here. Now I don't really need to extend it beyond my origin because I already know that's out of the option because of my other constraints. So there it is. Now I need to shade. This says y is less than or equal to this line. So I know, I'm going to shade with the yellow highlighter here, that it's less than. So it's going to be underneath this line. So I'm just going to do some yellow lines in here, so that I know it's under that line that's true for this equation. So we've graphed our third equation. Inequality. I keep saying equation. It's an inequality. Now I need to graph my fourth inequality. So x is greater than or equal to 140. Now, there's only one variable here. There is not a y variable. So the same way I had a horizontal and a vertical line with these two, I'm going to have a vertical line because x, it's going to cross the x-axis, so it will be a vertical line at 140. So if this is 100 and this is 150, 140 is going to be right about here. Okay? On Alex, you should be able to graph it exactly. I'm going to have to eyeball it just a little bit. That's about 140. And I do see that it's or equal to, so I can graph a straight line, solid line right here. And its x is greater than 140. So that means when I'm looking at my x-axis, the numbers that are bigger than 140 are to the right because we see 200, 300, 400, 500. So I'm going to shade to the right. Now, let's see. I'm going to do it with a pink pen. I'm just going to shade everything. Oh, if I get my pen to work. I'm going to shade everything over here. So you can see now, here's my overlapping area so far. All right. Now, we've graphed this one. So last but not least, we have y is less than or equal to 440 minus x. So I need my slope and I need my intercept in order to graph this line. I know my slope is the number in front of the x, the coefficient of the x. If I look, I just see a negative, which tells me there's a sneaky -1 in there. So my slope is -1 or -1 over 1. I like to put mine in a fraction because that helps me count it out. And my intercept is a constant or the number by itself, and that's 440. I always graph my intercept first because that's my starting point. So I'm going to go up my y-axis, 400, 450, 500. So my y-intercept is going to be about right here. Okay. Now I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Now I know you can eyeball it or use Alex to get the exact points for these, but since I don't have the option to use Alex, I know that where I start over here, if I'm going down 1 over 1 every single time, I should land on 440 over here. So I'm going to go ahead and trust that and put a mark on 440. Like I said, on Alex, you should be able to count 1 down over 1 or use the point button that lets you put in an X and a Y. But because I'm restricted, I'm going to do this. Now I look over here and I see that it is or equal to, so I'm going to go ahead and graph this line as a solid line right through there. And its y is less than that line. If y is less than that line, I need to shade underneath it. I'm going to use a green highlighter to do that. So I'm shading underneath it right here. So now that we've graphed each of these 5 inequalities, I can see the space that fits these requirements. So the region that fits these requirements. So this is my region right here that fulfills all the requirements outlined in this word problem. And that's how you do it. Some of the problems you'll see don't have 5 constraints. Some of them will have 5, some of them may have less. But that should help you with any of those kinds of problems.